Hello, and welcome to Backer Breaks It Down. In this episode, we are going to look at exponential functions. The comic that you see here is illustrating an exponential function. What do you notice? What do you wonder? Well, our little scientist friend is basically telling us exactly what we should be seeing. It says the bacteria are multiplying exponentially. And so you see the pattern is that the bacteria are doubling. You're multiplying by 2 each time to obtain the next value of the function. Okay, so this is an example of an exponential function, right? So an exponential function is a function whose equations contain a variable in the exponent. Now, our standard exponential function with base b looks like this, where you have the function is equal to a times b to the x power. A is representing the initial value of the function. That's the value at x is equal to 0. And b is the base. This is the change factor. Factor because we're multiplying. Okay. If b is greater than 1, then we're looking at a growth function, and we would say that that b value is a growth factor. And if b is in between 0 and 1, it's an exponential decay function, and b is a decay factor. So b goes, it's the base of the function, it's the change factor. We can specifically call it a growth factor or a decay factor, depending on the actual value of b. So let's analyze an exponential function. Number 1 says the balance B of t in dollars of an investment account is defined by B of t is equal to 5,500 times 1.12 to the t power, where t is the number of years. What is the initial balance of the investment account? Well, that's correct. It would be the value of A. So the initial balance is $5,500. Identify B. Is it a growth factor or a decay factor? Okay, so B is the base of our exponential function, and in this function, we're looking at 1.12. And since it's greater than 1, that makes it a growth factor. What is the balance of the investment account after 10 years? So this you're going to want to use a calculator for. You have a button on your calculator, it looks like this. Okay, upside down V, right? That's what we're going to use for our exponent. So I'm going to type in like 5,500 and then in parentheses 1.12, and then I'm going to hit that caret button, and then in this problem I'm going to type in 10. Okay, and so when you do that, you end up with a balance of $17,082.17. Okay, so far we have analyzed an exponential function. So let's write some exponential functions. Okay, so here in this table, we are given two exponential functions. We have g of x and we have h of x. Okay, now looking at g of x, the pattern that we see is multiplication by 3. Okay, they're multiplying by 3 consistently to obtain the next value of the function. So that would be your change factor, or the value of b in your exponential function. Okay, now when it comes to what is A is the initial value of the exponential function. And so this row right here is illustrating the a values of our two functions. So for g of x has an a value that's equal to 4, which is why the function for g of x looks like this. G of x is equal to 4 times 3 to the x power. Now, when you look at h of x, I bet you don't instantly see multiplication by 1/4. In fact, I bet what you see is division by 4. Okay, but the value of b is a change factor. It's what you multiply by. So we have to think division by 4, that is the same as multiplying by. And the key is if you see division, then your change factor is the reciprocal. So the reciprocal of 4 is 1/4, and that's what we're multiplying by, okay? And then for h of x, it has an initial value of 8, and that's how we get this function. So why don't you pause the video and try problems 2 and 3, and then unpause and check. Okay, all right. So looking at f of x, what I see here to go from 6 to 3 is, I don't know, my eyes see like division by 2, but remember, b is a change factor. It's what we're multiplying by. So division by 2 is the same as multiplying by 1/2. And then the initial value of f of x is 3/2. So for f of x, my a value is 3/2, my b value is 1/2, and I'm raising that to the x power. For g of x, when it comes to that b value, I have to look and see like what's going on here. And my eyes see division by 3, which is the same as multiplying by the reciprocal, which is 1/3. And then g of x has an initial value of 12. So g of x is equal to 12 times 1/3 to the x power. So how do you do? Okay. So here's a question, like, what if you can't see, like, easily what that change factor is? Okay, because this was pretty easy to see. But when you can't, you can calculate the change factor. Because in exponential functions with base b, equally spaced input values yield output values whose successful ratios are constant. Okay, and so I can actually calculate b by finding the ratio of f of b divided by f of a. Now, before you go freaking out, remember, this is just function notation. This is like x1, x2, y1, y2. So really what this ratio is saying is go y2 divided by y1. Okay. So in number 4, we are given a table showing the population of Russia. The population is given in millions. Part A says, like, let B be the ratio between the population of Russia in 1996 and 1995. So we're going to be using these values here. So I'm going to calculate B. B is equal to Y2, which is 147.6, divided by Y1, which is 148. So I calculate this, and I'm going to have to round my B value to 3 decimal places because it's not going to come out perfect. And I get 0.997. Once I know the value of b, I can write a function equation using my initial value for is 1995. So I'm looking at y is equal to the initial population of 148 times b, which is 0.997, to the t power. Use the function to predict the population of Russia in 2020. Okay, well, 1995 was year 0. So 2020, what year is that? Yeah, 2020 would correspond to a t value of 25. So that's what I want to type in for t on my calculator when I go to figure out the population for Russia in the year 2020. And so I got 137.3. And remember, this is in terms of millions of people. So 137.3 million, that's the population of Russia in 2020. Okay. And so there you have it. Exponential functions are functions that contain a variable in the exponent. A is your initial value. It's the value of the function at x equals 0. B is your change factor. It's what you're multiplying by. And if you can't easily tell what that is, calculate it, because b is equal to the ratio of f of b divided by f of a, which remember is simply y2 divided by y1. Those b values that are greater than 1 represent a growth factor, and those b values in between 0 and 1, a decay factor. And that's how Becker breaks it down.